特斯拉为什么需要 SimSolid?
Hi, my name is Alex. I'm a senior mechanical design engineer at Tesla working on the battery structures team. SimSolid was brought to my attention when Altair reached out to me to expand the tool's existing usage within my company. I figured it didn't hurt to take a quick peek at the tool during a time when I was already trying to run a lot of my own simulations and do my own analysis for faster turnaround time. To other engineers considering trying SimSolid, I'd say that you'll see an overall improvement in how quickly you can go from a concept to a fully finished, detailed design. Things go very smoothly when all of the inputs and outputs of a simulation are entirely in your control. You get to eliminate all of the back and forth with a dedicated simulation team that can often cost a few days when you need results within an hour. Once you have a simplified baseline, then you turn back to that team for the bigger, more complex models, having more confidence that your design will pass on the first try. The learning curve with SimSolid was super straightforward. Like any new software, there's a bit of shock when you look at a new interface and you feel overwhelmed with the number of things you can click. But what I found with SimSolid is that the necessary buttons to get a first model running are very neatly organized. There aren't too many things you need to find to start a simulation. And once you get the basics going, you find more and more options that you can tinker with to get more detailed or tuned models, making it feel like a low-skill floor, high-skill ceiling software. It's clear that it's tuned to a consumer that doesn't want to spend hours to do what should be a simple analysis. But if you're looking for something specific, it's probably there too. SimSolid has become an extremely integral part of my team's day-to-day design process without a doubt. We've mainly been using it for super simple models where we want to look at trends in a single part or a small assembly, or doing A to B comparisons between different designs for things like stiffness, stress concentrations, macroscopic behavior, etc. The other thing it's been very useful for is creating a quick visualization of deflection patterns or mode shapes, that kind of thing, where you have a result and you want to be able to just see what is actually going on within the system so you can find the most efficient solution. I haven't played around with SimSolid in the nonlinear domain too much, but sticking with simplified linear models is definitely the sweet spot for the group. I think we're living and working in an era where being efficient with your time is more critical than ever. There's enough ongoing projects around me that we can't afford to lose modeling or iteration time because we guessed at what would work. I like to say that guessing and engineering are mutually exclusive ideologies. Having an instant and simple simulation, even if just using block models, removes a layer of guessing to help you get to a properly informed and engineered solution that much quicker. It's a frustrating feeling when you spend a lot of time making a detailed CAD model for a part, just to find that it isn't even close to what it needs to be structurally, and you end up going back to rethink the entire concept. There's a huge net win in having some level of confidence in knowing that your concept has a functional basis before you spend time on it. That's where I think SimSolid's real value comes from. I've spent some time trying to use FEA tools in my native CAD software, but I've often found myself very limited on anything beyond a very simple single part force analysis. I felt very comfortable putting a fixed boundary condition on one face, applying a force or displacement somewhere else, and seeing what happens. But I didn't feel confident diving down the rabbit hole of trying to include multiple parts or anything beyond that. With SimSolid, it feels like working with assemblies consisting of 10 plus parts is no bigger challenge than working with a single part. Connections between parts are super easy and clearly defined. Boundary conditions and loads are straightforward with just the right number of options. Everything just works the way you want it to work. And when you get to the next level, you start realizing that SimSolid also has convenient tools for inertia relief, bolt pretension modeling, all that kind of stuff that could have been hacked up in a CAD-based FEA tool at best.